Hello everyone, my name is Arnaud Charlet. I'm the lead of product engineering at AdaCore. I will give you today an overview of what we've been busy working on, in particular in the past year, and so to give you a heads up on what's happening and what's going on in many parts of our technologies, including AWS. So I will cover mainly GNAT Pro and our ideas, and because there are actually other presentations as well dedicated to, in particular, QGen and Spark. So I won't cover them as part of this presentation. If you've ever opened the ticket on GNAT Tracker or support interface, you probably already know my name, and we've probably already exchanged by email. That's actually the main reason I'm here today and tomorrow. It's not for this presentation, but really for exchanging with you guys live as well. So if you have any questions you'd like to discuss, any issue you'd like to discuss specific to your project, I'll be very happy to discuss and hopefully answer your questions at any breaks. So please don't hesitate to grab me and ask me questions. I love answering questions. So. Okay, so GNAT Pro 17, which will be the release which will be available in a few months from now, this new release will include support for 51 platforms overall, 46 combinations across platforms, combination of host and cross configurations, and 5 native operating systems. So GNAT Pro 17 supports all versions of Ada, so from Ada 83 to the latest Ada 2012, including the latest updates which happened this year. So small updates on Ada 2012, the corrigendum 1 from this year. And we are actually already busy working with ARG, Ada Rapporteur Group, on the next version of Ada, so Ada 22X. Where there will be even more interesting features and developments about Ada, but I won't talk about it today. So GNAT Pro 17 will be based on GCC 6 and GDB 7.10. So I will go back in details on what this means for you guys in the next slides. Okay. Is anyone wondering why the next version of GNAT Pro will be 17? Where did GNAT Pro 8, GNAT Pro 9 and 10 go? No? Nobody? Well, I'm wondering actually, so, okay, let's see. Well, something we've realized not so long ago, about a year ago, is that, we had, let's say, a nice mess in front of us and in front of you in terms of product versions. We had all these versions on the left side are actually real product versions, so versions of GNAT, GDB, GCC, AWS, XML Ada, GPS, whatnot. That was confusing for us, that was confusing for you, clearly. And so we decided to actually make it much simpler, and so starting from the next release, all our products will have the same version number, which will be 17.1. So that will make it easier, and in particular, if you want to know which version is compatible with which other version of our products, well, the simple answer now will be if you take the matching version, if you take GPS 17.1 and GNAT Pro 17.1 and CodePeer 17.1, they will work together. Just for the record, tools such as GPS are able to support older versions of GNAT as well. So you don't have to absolutely match, but at least if you match the versions, now you will know that things will work smoothly. As an overview or a reminder for those of you who were here last year, so our release schedule, which is the same, has been the same for the past maybe 15 years, and so. Is to have our preview release actually that's a small change this year. Last year was in November, this year in October. So 1 month from now, we'll have the preview of GNAT Pro 17, which is called 17.0. So 1 month from now, you will have access to basically a preview of all the things I will present today in this talk. And then the major release, So the finalized release of GNAT Pro 17, called 17.1, will be available in February next year, and followed in July by the corrective release, which is a small incremental and safe fixes on top of 17.1, called 17.2, so in July. And then, again, same thing, at the end of the year, October next year, preview of GNAT Pro 18, so 18.0, and then 18.1.2 in February and July next year. So in GNAT Pro 17, we'll have new ports. In particular, we'll have support for processors embedded on iOS, iPad, and iPhones, so ARM 64 bits, basically, running on iOS. We'll also have support for ARM on PikeOS, hosted on both Linux and Windows host. We'll have support for ARM Linux with new latest ABI, so supporting hard-float ABI. We already supported the previous ARM Linux configuration for older ARM boards. And as well as we've generalized our support for cross-PowerPC Linux, and we now have a generic PowerPC Linux port, which basically is configured, well, can be tailored for any cross-PowerPC Linux distribution. There are several Linux distributions out there for PowerPC, and now our generic port is designed to support all of them. So as part of GNAT Pro 17, we have upgraded to a new version of GCC 6. And as part of these changes, we have now, in particular, many cases of improved code generation, thanks to the code generator itself, so GCC 6, and also thanks to improvements we've done in GNAT frontend itself for more ADA-specific constructs. So support for the latest chips and instruction sets, in particular Intel and ARM. So many improved optimization passes as well. That's for generic code generator, and we also have more specific to ADA language. We've also improved handling of control objects. So initialization, adjust, and finalization of objects is now more efficient if you are using control types in ADA. We've also removed generation of some redundant runtime checks. So runtime checks, which are generated automatically by the ADA compiler, are here to ensure that you will get an exception at runtime instead of getting some crash or random memory corruption. And there are some cases where GNAT has been optimized to avoid doing several times, basically the same check in the same subprogram, for instance. So generating a more efficient code in case of checks enabled at runtime. We've also improved array of handling of packed arrays. So packed array operations, some packed array operations are also more efficient now, generate more efficient code. And we've reduced, in some cases, the amount of stack and secondary stack usage related to some ADA constructs. We've also made improvements in the binder and the linker. So we've made big changes in the binder this year. And in particular, we have basically done a new algorithm, a new elaboration, a new algorithm to choose the best elaboration order given the constraints of your application. And this should in particular help people who are porting from existing other ADA compilers, non-GNAT compilers, to GNAT. That was one of the pain points that some of our users had when going from one ADA technology to another, is that the elaboration order chosen by the different ADA compilers are different, and in some cases we're causing lots of pain to some of our users. So we've put lots of effort to improve. So we have now a new elaboration order algorithm which should hopefully work better in more cases. And in addition to that, users can now even define their own constraints, which could be complete or partial with respect to elaboration. So they can provide basically an input file which tell GNAT, okay, I want to ensure that this unit will be elaborated before this one and this one after, and so on. And again, the GNAT binder will take all this information into account. We also support on Linux native platforms an alternate linker. So by default, we use GNU LD, GNU linker, and we now also support Gold, which is basically the linker developed by Google, Google LD. And that's a linker which basically provides, well, the same capabilities, which is to link programs together. And with one of the nice properties of Gold is that it's usually faster, and in some cases much faster than GNU LD. So if you are spending in your builds lots of time linking, creating executables, creating libraries with the GNAT toolset on Linux, then have a look at this alternative, which in some cases can make a big difference. We have a customer who tried it, and in some specific configuration, they went from 12 minutes to link to something like 15 or 20 seconds, to give you an idea. So it can make a big difference in some cases. So as part of updating to new GCC, we also have new improvements on, with respect to support for C and C++. So that's in particular, so this version of GNAT Pro and GCC have full support for the C++ 11 and 14 standards, and also including partial support for the next standard, which will be C++ 17, which is still under design. And more importantly, for you, the default mode has changed for C and C++. So if you are using GNAT Pro C or GNAT Pro C++ to compile your code, if you have C and C++ code, know that now with GNAT Pro 17, the default mode for C will be to use basically the C11 with a few GNU extensions as default, whereas the previous default was basically C89, which might create some additional warnings or even some additional errors in some cases, because the new standards, C or C++, are stricter in some areas. If that's the case for you, well, there is an easy way out, which is to revert to the previous standard. That's just a compiler switch to add. So the compiler switch is available. So it's just the default which is changing. Or, of course, to improve your code if you want to follow the latest standard. So you will have both choices. The simplest path, if you have any trouble, will be to use an explicit switch to revert to the previous standard. Same for C++. There were many improvements in diagnostic machinery, so more precise locations, offering suggestions on how to fix your code for C and C++, similarly to what was already available for Ada. And again, a feature which has been available for several years now for Ada, which is scalar storage order capabilities. That's a way, that's a pragma or an aspect in GNAT for Ada, and that's an attribute for C, which allows you to easily choose the internal representation of your data structures, and in particular when you are porting code, let's say for instance from Big Indian platform to Little Indian platform without having to change all your code, then that's one way to do it, is scalar storage order capability. So again, it was available in Ada, and it's now available also for C. So concerning VxWorks platforms, we've done also many improvements on VxWorks this year. In particular, so improved module load speed in the debugger. So it's much faster now to load a module to debug on VxWorks. We'll also provide this year something which we were already providing on all our native platforms. We have been providing for many years now our internally generated ECAT certificates, showing that GNAT Pro has passed all the ECAT tests, which is Ada conformity test suite, successfully. And we will also provide these certificates on all our VxWorks 6 platforms this year for the first year. And as a reminder, since last year, we now support, well, most if not all versions of VxWorks. In particular, on VxWorks 7, we support almost all processors, well, all the processors that matter to you. So we support ARM, PowerPC 32-bit. We are even working, probably not in GNAT Pro 17, but we are working also on supporting PowerPC 64-bit for VxWorks 7. as well as E500 V2, which is a variant of PowerPC processors, and x86 64-bit processors. On bare metal platforms, we've made one big change this year. Is we've defined an extension of the Ravenscar profile. So as Jimmy mentioned, Ravenscar has almost 20 years now, and so we decided that it was probably time for an update. Now that more and more people are using Ravenscar, we have some feedback on the field on what's useful, what's potentially missing on Ravenscar. We're still having strong properties of Ravenscar, which is schedulability and predictability in particular. And so we've extended the Ravenscar profile, and we are also working again with ARG to actually standardize these extensions. So far it's GNAT-specific extensions, but we are also working to actually include these extensions as part of a new profile for Ada itself, for the next Ada standard. And so in this extended Ravenscar profile, we'll have support for multiple protected entries in protected objects, which we are limited to one protected entry in Ravenscar so far. Support for queues, protected entry queues, which was also not supported in Ravenscar. Well, in Ravenscar, you had a queue of one potential element, one potential task only, but now you will have a queue which will be potentially unbounded. You will have the option to bound it to X number of entries if you wish so, or unbounded, depending on your needs and constraints. Support for relative delay statements and the calendar, Ada.calendar package. And also relaxed restrictions on the protected entry barriers. So you will be able to use more complex protected entry barriers as part of this extended Ravenscar profile. On the ARM platforms, on bare metal, we'll have also easier runtime customization. So ARM is a very large and complex family of processors. And so we made it easier this year to configure the GNAT runtime, the Ada runtime for your specific ARM board. So we don't provide support or BSPs for all possible ARMs because there are really literally hundreds, if not thousands of them are out there. But we made it easier to provide referenced implementations and to make it easy for anyone to adapt, to customize these runtimes for specific boards. And on the Leon and Leon 3, which are the Spark processors for space, we've added support for SMP. So now multi-core Leon, which is Leon 3. Leon does not support multi-core, but Leon 3 does. So SMP support is now included in our bare metal runtimes, and also support for hardware user initialization. A few changes this year on native configurations. So native configurations, one of the changes that AWS will now be included by default in all our subscriptions. So up to now it was a separate add-on, and now AWS is part of all GNAT Pro subscriptions. So if you had not had a chance yet to have a look at it, you will now be able to use it out of the box. So AWS stands for Ada Web Server. That's a way basically to embed an Ada Web Server inside your application. And AWS will now also come pre-installed, pre-compiled, so pre-built with GNAT Pro. So you won't even have to now build it. You will be able to just, after installing GNAT Pro 17, use it out of the box. And that's the same for XML Ada. That was, we already had done that for XML Ada for a couple of years now. And we've also done it this year for GNAT Core, so GNAT Component Library, which is a library of various utilities available again, so pre-compiled again for all our users. That's particularly useful on Windows because it was easy to build AWS, GNAT Core, XML Ada on Linux platforms, but on Windows, it was always a bit of a challenge for customers to build and use these libraries, and that's the main reason why AWS, GNAT Core, and XML Ada now come pre-compiled. So concerning the debugger, we've added a few improvements in the debugger. In particular, the exception message associated to an exception occurrence, is now displayed in the debugger when you stop, when you break on an exception. It's now also possible to switch from one task to another when debugging a core file. So previously it was only possible when debugging a live executable, and now if you do a post-mortem debugging on a core file, you can also inspect values and stacks of your various stacks from the debugger. And finally, we've added an option which basically allows GDB to start more quickly in some cases. In particular, some people want to launch GDB in a scripting environment to generate a core file or to do some specific actions, and so they don't need to load the debugging information. So this option is available in these specific cases. Concerning GPRBill, which is our multi-purpose and multi-language builder, so several improvements this year. In particular, so now there is a build script switch, which is able to generate a standalone script, so a standalone shell or batch file for Linux or Windows, and basically allows you to provide a complete trace evidence of what all the steps were taken and used for doing your build, and to allow reproducing a build from scratch without using a GPRBill, without using any project file, just using this script file. So that can be useful in some environment to control the build and to not depend on too many tools. The default output has been redesigned. So the default output is now, let's say, simpler, lighter. It provides basically high-level information about the various steps of build, so compile, bind, and link, and information about which file is built with an Ada or C or C++ compiler. There is a switch, so you can use the -v verbose switch to go back to basically a more verbose output, which is similar to the previous default. So if you still want to double check which exact switches are used for which exact file, that's possible. It's just no longer the default. We've also added improved handling of configurable runtimes. So in particular for bare metal and cross configurations, GPRBill now is much better integrated with all these configurable runtimes, and it's much easier to specify them and to use them out of the box. We've also added support for response files during compilation, which is a way basically to avoid long command line limitations. We already were using it for the link. And in some extreme cases, it was also needed for the compilation itself, when you have a huge, very long list of switches. So now GPRBill automatically, when needed, when the command line is too long, will use response files also for compilation. We've announced support for shared libraries on native platforms. In particular, so what we call encapsulated libraries, which are basically fully standalone libraries, which embed the Ada runtime, embed all your code, all the dependencies in your code in one specific single library, is now supported on all Linux platforms. In particular, it was not supported so far on Linux 64-bit, and now it is. And with that, we've introduced a new library, can static pick, which basically allows us to implement support for encapsulated library on all platforms. And you can also specify exactly which, you can specify that your shared library will only export visible symbols to external users of your library, and limit it automatically to symbols part of your library interface. And so all the symbols part of basically your implementation will be hidden and won't be available to third-party usage if you wish to. So that's an option. And we've also done many improvements, stability and usability improvements in support for distributed build. So as a reminder, GPRBill has an option to GPRBill can distribute builds on one machine on all your cores, on multiple cores. That's a -J switch. but GPRBill goes beyond, and GPRBill also supports builds distributed on several machines, several computers in a network. So if you have several fast computers in a network and you want to take advantage of them to get faster builds, you can use it using GPRBill distributed. And so we've done many improvements in this area this year. Just before finishing on GPRBill, so GPRBill is, as soon as you are using project files to build your project, our recommendation these days is really to use GPRBill, which, similarly to GPS, supports, by the way, several versions of GNAT. So you can use the latest version of GPRBill or GPS, and you can still use older versions of GNAT. So you can use GPRBill to drive GNAT 7 or GNAT 6 or GNAT 5 for that matter. So GPRBill can be used with all versions of GNAT. And now with the latest version of GNAT, GNAT Pro 17, we've removed support for project files in GNAT Make, which is our other legacy builder. And what will happen is that you can still actually use GNAT Make on a project file, and GNAT Make automatically will call GPRBill now. That's something to be aware of, that now you will, whether you want it or not, when using project files and GNAT Make in GNAT Pro 17, you will actually use GPRBill under the hood. All right, GNAT Test. So GNAT Test is our unit testing framework. And this year we've done many improvements related to stubbing. So we've introduced support for unit testing stubbing last year already in GNAT Test, and this year we've made many improvements in this area. And in particular, we support now a generation of stubs for subparam in private part of your packages. Also generation of stubs for parent packages when you have parent and child packages. And you can also specify to exclude some units in this stubbing mode. So that's really basically completes support for stubbing in GNAT Test. So as a quick reminder, stubbing is basically about concentrating your unit test on one specific unit and stubbing all the calls which are done by this unit. So this unit depends on many other units, but as part of unit testing this unit, you may not want to also test the code of all the dependencies. So you want to stub the dependencies to provide basically just controlled input and output of your dependencies without being influenced by the behavior of the actual code from your dependencies. So that's what stubbing is about. And we have also improved integration of GNAT coverage. So GNAT coverage is basically complementary to GNAT Test. GNAT coverage is our code coverage tool, which complements unit testing. So you get unit testing or integration testing, and then you run a coverage tool typically to verify how well and whether your code is fully covered or not. And so GNAT coverage is it's a tool which has been already qualified in the context of several avionics and railway projects. So it has been, we have written all the qualification material for DO-178B and C, and for railway, EN 5128. So that's a tool which can be qualified again in the context of your projects if needed. So that's something which is available. And so GNAT coverage supports all levels of coverage required by the avionics standards. So level, basically level A, B, and C, well, C, B, and A, which is statement coverage, decision coverage, or MCDC, modified decision coverage. So GNAT coverage supports all these modes of source level coverage, as well as object coverage. So object coverage has been improved also as part of this new release of GNAT coverage. Support for new platforms, so support for ARM, ELF, and native x86 Windows has been finalized. We are actually also already looking at support for x86 64-bit Windows as well. And also support for incremental coverage analysis, so allowing basically consolidation from intermediate results. So you do a coverage on one part of your application, on another part you get partial coverage information, and at the end, GNAT coverage is now able to consolidate all this information in a single synthesized report. And also support for stub coverage as well. That is to say, similarly to what I described for stubbing in GNAT test. And now GNAT coverage is able to basically only concentrate and generate reports for the specific unit of interest, and ignoring the coverage of the stub units, basically. So again, helping doing stub testing, stub unit testing, so with GNAT test and GNAT coverage. Okay, at this point I've had lots of bullet points and text, so now I will switch to a more, let's say, screenshotty way of presenting things, hopefully trying to wake you up if you are sleeping. So we've got also lots of nice improvements in GPS, which is the GNAT Pro IDE this year. So in particular related to support for the debugger. So we've implemented a new debugger perspective. So by default you get this new perspective with a call stack on the right, your source code, and you get a debugger console, and you get this new area with breakpoints and debugger variables on the bottom right side. And going into the details, so we got a new variable tree view in GPS to graphically display the contents of your data structures. So up to now, and it's still available, we got a way to display data structures in actually a browser, so in a graph way where you got basically boxes and dependencies, rows between the boxes. And many users asked us also to provide a more, let's say, traditional tree view of your data, which is what will now be available in GPS 17. So if you have a record with several fields, you can display all the values of your fields. And if the field itself is a record, again, you can enter and see the values. And same for pointers. If a value is a pointer, you can dereference it by clicking on it and following the various values in a tree way. We've also redesigned the Breakpoint View. The Breakpoint View now is basically has been redone almost from scratch. So it's basically simpler, lighter, easier to use, and more intuitive. And along with the breakpoint view, it's now also possible to set breakpoints before starting the debugger. So up to now, you needed to enter the debugger session to be able to put breakpoints on your application. But several users pointed out that it's when you are in your source code, in your sources, not necessarily in the debugger, that you might want to already decide, okay, I want to look at this subprogram or this specific line in my subprogram, so I want to put a breakpoint, and I don't really care that the debugger has not started yet. I want to tell you, okay, I'm putting a breakpoint here, and whenever the debugger will start, of course, please put the breakpoint for me. So that's not now possible in the editor without starting the debugger. On the side now, you can put directly breakpoints by clicking on the corresponding line. We've also improved the call stack view. The call stack is again simpler by default, and also I don't have a screenshot here, but basically we display only the basic information in the call stack view, which as a result also is faster to display and refresh. We had in some cases of big applications the call stack view, which was slow to refresh because the underlying debugger was recomputing all the parameters and all the variables associated to each frame. And now that's not done by default, which allows us to display faster the call stack. So each time you step into your application or you step in a breakpoint, the call stack view is updated automatically, and now that's much faster. And we've also enhanced Python scripting, and in particular related to the debugger again. So now, many operations which were not available as part of the Python scripting capability of GPS now are. So you can basically completely script and automate your debugging session using the Python interpreter as part of GPS. So if you want to automate debugging or automate testing using the debugger, it's now much easier to do using this improved Python scripting API. And finally, as part of the debugger, we've also improved support for embedded debugging. So in particular, we've added support for OpenOCD, which is well, a set of tools for flashing and debugging flashing and debugging on your boards easily. So being able to flash, to load code on your board and start your executable on the board easily when you are in particular on bare metal configurations. Okay, finally on GPS, many other things not related to the debugger. I won't go into the details here, but we've also redesigned many other things such as handling of bookmarks. We've also redesigned the preferences dialog, which now includes some capabilities which were separate, now are included in the preferences. So handling of key shortcuts, handling of enabling, disabling, choosing which plugins you want to have is also now part of the preferences dialog. And online help messages to help you use this new preferences dialog. We got also now a menu bar separately on each floating windows. If you are using several floating windows in GPS, now you will have the GPS menu bar on each floating window. And we've improved performance in several areas. In particular, handling of the project view is now faster. Search and replace in some cases is also much faster, and loading of messages from tools is also faster in general. Our other IDE, GNATBench. So GNATBench is our plugin for Eclipse. That's our integration in Eclipse, which we recommend to use in particular whenever you are already using an Eclipse environment. So that's typically the case for if you are using all the VxWorks platforms. The VxWorks IDE, which is called Workbench, is based on Eclipse. So our recommendation when you are using Workbench is to use GNATBench for ADA support. And same thing if in your company you have decided to standardize on Eclipse for most of our tools, then our recommendation also is to use GNATBench. And so this year we've added support for last version of Eclipse, so Eclipse version 4.6. And also support for VxWorks 653 3.1 and Workbench version which goes with it. As well as some additions. In particular, we now have ADA template code assist. So in order to help you write ADA code quickly, so if you want to write a new construct such as a procedure, an if statement, a case statement, now Eclipse with NetBench will create templates for you that you can then complete manually. And we've also integrated all the examples related to Aegis. So Aegis is our technology to link between ADA and Java, ADA and Java Virtual Machine, which is used by NetBench itself and by some of our customers who need to integrate ADA code inside Java environment. And so the Aegis examples are now integrated into NetBench directly. And finally, as a reminder, because Jimmy already mentioned it, but we will start our yearly customer survey campaign in November. So we did the first customer survey last November, and we will do it again this year in November. And we will need to know from you how we are doing, what we could do better, what we can do to help you. So this customer survey is more for your colleagues and people you know, but certainly the survey also starts today and tomorrow, so please don't wait for November to give us your feedback, and don't hesitate to take advantage of the break, which is about to start, or the next ones to come and discuss with us and give us your feedback. Thank you.